Hi everyone, I am Balaji Chippada and welcome back to my YouTube channel. In continuation of our series Probability and Statistics, in this video, let's understand one more very important feature of a normal distribution, which is 68, 95, 99 rule. So without any delay, let's get started. So in the previous videos, we have learned about what is a normal distribution and how are we going to represent a distribution as a normal distribution given that we have mean and variance sigma square. This is a variance, so this is called variance, and we have something called sigma called standard deviation, right? And look, we have looked at how mean and variance changes and how the plot will get changed, right? So let me rephrase that again. So we have normal distribution Wikipedia. I use Wikipedia a lot because it provides extensive knowledge, guys. So if you remember this plot, we have seen this, right? Now in this video, we will learn something called as 68, 95 and 99.7 rule. This is very interesting and important rule, and let's understand what this is. So here we have a normal distribution and the mean is at 0, and we have learned that in case of a normal distribution you have 50% of the points on the right side and 50% of the points on the left side. Clear? And this is a symmetric graph, symmetric plot, right? So let's say my data set is X and it is following a normal distribution with mu and variance sigma square. Now what this property tells is, so given that we know the variance, we can calculate standard deviation, right? Which is basically square root of variance. So let's assume my mean is 0 and variance is 4. That means my standard deviation is 2. And what we learned in the previous video, standard deviation and variance is basically how far are your points from the mean. So that is this intuition. Now what normal distribution says is, if you know the variance or standard deviation and also the mean, I can say that approximately 68.2% of points of your dataset X lies in between minus 1 sigma and 1 sigma. So which is minus 2 and 2. So let's say I have a dataset X. So let's assume it is 1000 points. I don't care about what these points are, but I know for the fact that the mean is 0 and the variance is 4. That means standard deviation is 2 and it follows normal distribution. Then I can conclude exactly that approximately 68.2% of values lies in the range of minus 2 to 2. That is what a normal distribution property is. And if I go to 4 to minus 4, I would have 95.45% of the points lying in that. And if I go to 3 sigma or 3 standard deviation, I would cover 99.73% of points. Hopefully that is clear. And if you have any queries, please let me know in the comment section below. So let me rephrase what we have learned so far. If I have a normal distribution and if I know mean and variance or standard deviation, I can conclude that approximately or exactly 68.27% of the values lies between minus 1 standard deviation and 1 standard deviation, and 95.45% values lies between minus 2 standard deviation and 2 standard deviation, and 99.7% of the values lies between minus 3 standard deviation to plus 3 standard deviation. So this is a property that we have. So now you might ask, why is it helpful and why are we learning this? So let's say someone did some analysis and told you that I have distribution of people's height in America. Let's assume like that. And I'm not sure how many points they are and how many people they calculated, but they told that this distribution follows a normal distribution in such a way that its mean is 160 and then variance is 10, or maybe you can say sigma square is 100, which is variance is 100, and if I have to calculate standard deviation, which is 10. So if I know this, let's say I have a population of people's data in which their distribution follows normal distribution, in which mean is 160 and sigma square is 100 and standard deviation is 10. That means that approximately 68.2% of people's height in America would be ranging from, what is this? This is my mean value, and I have to subtract minus 1 sigma, which is minus 1 into 10. So 150 to 170. So 150 to 170 centimeters is the range in America, such that 68.2% of people fall in that region. And if I calculate 2 sigma, which is 140 to 180, so approximately between 140 to 180 centimeters height range, I would have 95% of the people population, and between 130 to 190, I would have approximately 99.73% of people's height. So without even looking at the data points, without even looking at the people's height, by just knowing that I know the distribution follows a normal distribution with the mean and standard deviation, I can make these conclusions. So that is the power of a normal distribution. That is why we are learning these things. And in most of the interviews, you will be asked these questions. Explain 68, 95, and 99 rule. So in general, we call it as 68, 95, and 99 rule in terms of a normal distribution. Hopefully that is clear. If you have any queries so far, please let me know in the comment section below. I will be able to help you out without any issues. That's all for this video, guys. Hopefully you learned something new from this video, and if you are liking what you are watching, a sub to the channel would be amazing, and click that bell icon to get notified daily. We will meet in the next video. Bye bye.